Okay, when the number of the equation is equal the number of the unknown well, in this case, it's the most popular, no? The system is determined. So our system is determined. Of course, determinate system. It's an adjective. The noun is system. We have three possibilities. The classical three possibilities, you know. One solution. Infinity many solution. Okay, it's the part that you need to determine the free variable. No solution. So that depending of the equation. For example, see, we have one equation that you don't see at the beginning, but actually it's linear depending of another. Immediately, the elimination process, Gauss elimination process, discover this. And you see in the example now. Another possibility that we can solve is when the number of equations is less than the number of unknown. For example, suppose we have only two equations and we have three variables, three unknown. So the classic XYZ, three variables, and we have two equations. In this case, this system is called underdetermined. Underdetermined. Yeah, determined system. In this case, we have only two possibilities. Or we have infinity many solution, or we have no solution. But never we have one solution. Never. It's impossible. Suppose to understand a little bit more clear. Suppose that we have in two dimensions, we have one equation. It's a line. It's a line, so we have infinity point, the solution. Suppose more clear. In three dimensions. In three dimensions, you have, for example, two equations. And two equations represent 3D, two planes. And two planes touch each other in one line. So we have infinity many solution and one free variable. But never we have one solution. So we can erase this because it never happened. This idea clear or not? Geometrically speaking, what is infinity many solution? Infinity many solution. Infinity many solution. Okay, same. Okay. Infinity many solution. So you understand very well. This is important. Geometrically speaking, okay, when you have a lack of equations, my problem is 3D, where you have only two equations, or my problem is 4 dimension, and we have only 3 equations. It's impossible, geometrically, it's impossible to have one solution, 1 point solution. Okay, and number 3, when you have a number of equations greater than the number of unknown. It's called, by the way, overdetermined. This is because supposedly we have too much information. Indeterminate system. Entonces you can find one solution. But one solution is very weird, very hard, very or probably. I want to explain why. Infinity many solution and no solution. Suppose a problem in 2D, so two variables, x and y. X and y. This is the classical rectangular coordinate system in 2D. And you have, for example, 4 equations. 1, 2, 3, and 4 equations. Suppose that the first equation determines this line. The second equation determines this line. Because I suppose if we have no more equation, this equation is deleted. This is the solution. You need solution. But suppose you have one more equation, and by coincidence, passing through the same point. And entonces now, okay, no problema. No problema. Elimination process, user matrix discover this idea and determine the solution. I suppose that the last equation, no passing for this point. Es obvio que no solution. Bueno. Equation es bueno, professor, easy if pass. Okay, entonces, yes, we have solution. But it's very probably. So no probability. The probability is too hard. No solution. No happen. Geometrical, yes. But it's very important. Now when you increase the dimension, is less probable. So basically, infinity many solution or no solution. I bring today a lot of examples to illustrate very well this situation. Okay? Frequently, so my objective today is I give you the system, you convert to the matrix format. You need to learn very well how you set up the matrix inside the GeoGebra. And after the interpretation. Suppose the example 1. In example 1, we have x minus y equals 6. Equation 1. 2x minus 3z equals 16. Equation 2. And 2y plus z equals 4. Equation 2. This is my system that contains 3 equations, 1, 2, 3, and 3 unknown, que es x, y, and z. Okay, now write the automated matrix that we're using to solve this. Okay, remember, the format is clear. You open the square bracket. You, for example, thinking one column for the x, one column for the y, one column of the z. I separate, this is just a style, by the vertical line, because this is the right-hand side number. And horizontally, you have one equation, equation 1, equation 2, and equation 3. So always there are perfect coincidence in between the number of rows of the matrix and the number of equations that we have in the original problem. No? So says 1, -1, no z, and 6. This is my first equation expressed in matrix language. The second one is 2, is 0, y, no y is missing, -3, and 16. And now in the last equation, we have no x, 2y, 1z, and the right-hand side. By the way, this automated matrix is the combination, the matrix with the coefficients in from the variable plus the right-hand side number. And the dimension of this matrix is, this is the most like the lecture we learned from the test number 1. Okay. Entonces test number 1? No, I don't see so. The dimension is 3 by 4. So this matrix contains 3 rows, 4 columns. Okay. So far, everyone have a question or no? No? No. Okay. Now let's move in to the GeoGebra. GeoGebra is the software. Is totally free. It's online. You can use it online, or basically I like download the application, but no, you don't need to do necessarily. You download it better, but it's fast. You can store the document, so the script you create. But no, the student que want to use it one semester, not necessarily download. You work it online. Entonces, the software, the name is GeoGebra Classic. GeoGebra Classic. There are many software, guys, to do this. Personally, I like this. Classic. I like this because I consider it better. Consider that, there are enough space to understand the thinking we are doing. Another software, no. Another software have advertising. Entonces, no good. Okay, entonces GeoGebra Classic. When you open GeoGebra Classic, so you open the browser, Google Chrome maybe. I don't know. I like Google Chrome. You put in the taskbar GeoGebra Classic, and you open. And when you open, you see something like that. Let me try to open. Open. Do you see GeoGebra? There are two GeoGebra. One GeoGebra for geometric. No, this is classic. Okay, include both. Include geometry and include algebra. Okay, do you see or no? All right, answer me. Yes, no, in the chat. This is for industrial. What the hell? Okay. Giselle, yes. So Giselle, normally default, when you open GeoGebra, you see two windows. Okay, by the way, you can change the width of this. Drag this. This is the algebra. This is called algebra. This is called a graphic. It's obvious, right? Makes sense. You are doing graphic. Similar to the Desmos. A little bit more complicated, but Desmos is nice. But this is good also. So now you go to the three line this to expand the menu. Okay, this is my account. Look at my last name, and this is my age, 7 years. Now you change the view, because for working with the matrix you need another view. You click in view, and I don't need graphic, so I delete graphic. I have only one window, that is algebra. But you put available CAS. CAS is computer assisted software. Okay, is the brain. You compute everything we studied in this chapter on CAS. And you open also a spreadsheet. The spreadsheet look like Excel, but actually it's not too powerful like Excel, no? But you will using the spreadsheet like a matrix editor. Entonces in any place of the spreadsheet you type in using your own keyboard. You type in the matrix. Okay, my problem. Okay, the matrix, and my problem was you let me know if I make a mistake. Not necessarily typing in the first cell. No, you type in any place. Here, for example, 1. Press tab to navigate horizontal. The 1. Tab. 0. Tab. 6. And this is my first equation. Press enter to come back at the beginning. 2, 0. No y in the second equation. Minus 3. Get the coefficients in front of the c. And top 16. It's important, guys, that you take your time to type it well, because if you change something, you change one number or you change one sign, of course you are solving totally different problem and don't expect any correct solution. No? In the last equation we have 0, no x, 2y, 1c, and right hand side number is 4. Boom! I finished to type in the number. I suppose that I did well. Just in case, I would like to check it in my piece of paper. Yeah, I guess so. Everyone follow me so far? Would be good. Would be good. Well, depende, no? So you have a space in your laptop, because you basically, when you are watching the lecture, you open the audio. Well, no. You after that, I would like that you practice looking the video. When you watching the video, you are trying to do by yourself. No. It's confused. Maybe I confused. Now, I have the array of number. I select and select totally and press in the mouse the right click, open this pop menu, and you try to find create who? Create the matrix. Create matrix. And when you click on matrix, automatically you see in algebra the matrix by default they call M1. But you can rename if you want. If you want to rename, let's do it at least the first time. But I like M1, M2, M3, M4. When you have several matrices, it's a good idea. So you want to rename, you click on the matrix, specifically click on the name. Suppose like you wrong. And you select the option rename. What new name you put? You put any name, Maria, Jose, whatever. I put matrix A. Because normally in the piece of paper, you call matrix using capital letter. Copy with the capital. And you click OK. Now the name of our matrix is A, not M1. So now when you finish this edition of the matrix, you go to the cast. You click in the first line of the cast and you type in the famous function reduce it. Doesn't matter if you start with the capital letter or lowercase. Automatically cast recognize the function and you select the function, but you have to possibility. And I select user matrix, and the matrix in our example I rename like A. And you press enter to perform this function. Bam! And this is this. Okay, so now I want to understand this result. I want to make the screenshot. Specifically this part of this matrix. Why not? Let me see where I save. Yeah, in the same folder of the our class. I put it example 1, E1. Okay. No, much better example. Example 1. And save. Yeah, I come back now to the whiteboard. Okay, let me try. Let me try to share my whiteboard now. Switching to whiteboard. Yeah, there you go, whiteboard. Do you see now my whiteboard?
Yes.
Yeah. Okay, now Giselle. I try to find the image of the screenshot. So the name was example one. Example one, there you go. Yeah, open that. Boom, too large. Okay, so now after, and the test guy, you put the arrow here, and this acronym is reduced row echelon form, and you convert that matrix to this matrix. Okay, now interpretation. Remember, the first column is X, the first column is Y, this third column is Z, and this is the right hand side number. If you, for example, you translate the first row to equation, you see 1x plus no y plus 0z equal a. Okay, by the way, this is equivalent to say that x is equal to 8. Likewise, x is equal to 8, y is equal to, and z is equal to 0. 0 is a number. Therefore, you have unique solution, and this unique solution occur at the triple order a, 2, 0. End the story. Cool? Any question? Cool? Definitely cool. It's amazing. So now, let me try to generalize. When you see this format, guys, after the famous reduced row echelon form, so you see this format. Doesn't matter si it's 3 dimension, 2 dimension, 4 dimension, any dimension. You see that the main diagonal, suppose 4 now, to change something, 4 dimension. Suppose you have 1, 2, 3, and 4, 1, and the rest is 0. 0, 0, 0, 0, 0. Remember the algorithm of the Gauss-Jordan? Create a pivot, 1, 1, 1, 1, 1 in the main diagonal, and the rest using row operation, you convert to 0 below and above the pivot. And suppose you have, for example, here 20, 30, negative 10, and 40. Well, so my answer is, suppose the variable is, x, y, z, w. When you have more than 4 dimensions, you call differently. You call x1, x2, x3, x4. This is classic, but no, you can call it any way. But in this case, you see clear, guys, in that part, we have one matrix is always 0, except the pivot is 1. And this matrix is called identity matrix. Identity matrix. And the reason it's called a matrix matrix, you understand? No, now. You understand in the next chapter. So 2 more chapters. But okay, is for example, identity matrix dimension 4 is this, because it's 4 by 4. It's a square matrix. Identity matrix dimension 2 is 1, 0, 0, 1. It's 2 by 2. Identity matrix dimension 3 is 1, 1, 1, 0, 0, 0, 0, 0, 0. That's 3 by 3. This is one guy, sorry. And so on. Well, you have identified dimension 1, it's only one, like a scalar, no matrix. So it's just 1. But you put the bracket to specification that we talk about 1 by 1, no? It's one element. And so 5 by 5, 6 by 5. Okay, so now the conclusion in this example is clear. X is equal to 20, Y is equal to 30, Z is equal to negative 10, and W is 40. So this is the typical format for the unique solution. So it's the famous identity matrix dimension M, line, and the right-hand side, okay, I want to call B. But the important identification is that you have here the identity. In other scenario, no. Okay, this is my first case. Let's do, why not, another example. So you have no question, no? Example 2. Example 2 is 2x minus 2y minus 2z equal to equation 1. 2x again, wow, plus 3y plus z equal 2 again, wow, look like similar. And 3x plus 2y, no z, it's missing, equals 0. Okay, no problem. You don't need to predict anything. No, you only apply the systematic procedure, and the procedure tells you what is the truth of this. Let me try the matrix. The matrix 2, negative 2, negative 2, bar 2. 2, 3, 1, 2. 3, 2, 0, 0. It's 3 by 4 again. Okay, now I go to the software, GeoGebra, and perform the famous reduced row echelon form function. Suddenly, well, I don't know. Let me try. Switching to. You let me know so you see the chain there. GeoGebra Classic, switching window. Do you see? We see. Entonces, bueno, okay, what should I do, Professor? I delete that part? Oh no, if you want. No, not necessarily delete. You type in the new coefficient in any place of the spreadsheet. This is the beauty. This is the reason why I like that. If you want to delete, okay, no problem. Delete. You select this. You press your keyboard delete. Wow, that's it. Okay, you want to recover this information. Control C is undo. Wow, stay the same. But not necessary. You know? I like delete. New problem, new. But sometimes, another example that we are doing, we need several matrix, not only one. In this example, yes, only one. Okay, delete. Why not? Change the place. Suppose this is 2. Tab. Negative 2. Negative 2 again. Oui. Second equation. 2. Positive. And 2 again. 2 again. Yeah. Press enter. Last equation. 3. Up. 2. Up. 0. It's important. The empty space. To indicate that in the third equation, the C variable do not participate in this game. Okay, this is my matrix. Now I try to select the array of number and create like a matrix. Remember, in the mouse, right click, you open the pop menu. There are many possibilities, copy, paste, cut, delete. But in this case, I create matrix. This is the matrix N1. I don't want to rename N1. After in the cast, I put a reduce row, reduce echelon of the matrix N1. Press enter to confirmation the command. Boom! I get this answer. Okay. Wow, I'm confusing. Oh, no, not confusing, to save the word of the screenshot. No, not screenshot anymore. Let's move on to the whiteboard because I have in my piece of paper the copy of this. Let's analyze the interpretation of this. Okay, look. Switching. Whiteboard. Okay. Whiteboard. Do you see whiteboard? They make the game. Yes. Contain fraction, but it doesn't matter. Doesn't matter getting fraction. Yes. S1, S0, S minus 2/5, 2/5, 0. This is a line that separates the features on the right hand side. 0, 1, 3/5, 0, 0, 0. Wow, too many 0. 0 and 1. Okay, interpretation of this result. Well. You see clear. In the last equation, that one, you take a look always the last. You see a contradiction. Because remember, this is X, this is Y, this is Z, this is the right hand side. So you see que 0x plus 0y plus 0z is equal 1. This is 0 is equal 1 is, of course, totally untrue, is false statement. And you know very well when you get false statement in the other chapter, we're doing by hand everything. You see false statement is because we have no solution. Clear? The fantastic way to determine no solution is take a look the last equation. Si you see contradiction, entonces es no solution. You see another example in which is no false true because suppose que es 0. Ooh, si es 0 here, I don't know. I need to understand this now, pero no. No. After. You understand very well no solution? Example 2. Yes or no? Well, yes. Example 3. Example 3, I want to complicate a little bit your life. I put a big system that contains 4 equations and 4. Good. X plus Y plus Z plus W equal 4. Equation 1. X minus X, plus 2Y plus C, no W is missing in the second equation, equals 0. Third equation is 2X plus 3Y plus C minus W equals 6. Third equation. And the last equation is minus 2x plus y minus 2c plus 2w equal negative 1. Okay, we have a system that contains 4 equations and 4 unknown. X, Y, Z, and W. According to our classification, it is the determinant system. As you expect any possibility, any one solution, infinity many solutions, or no solution. Okay, you have no idea, therefore you, in the piece of paper, you organize your matrix tools. This is the column of the X, this is the column of the Y. When you have practice, you don't need to write this. This is stupid. This is one. You prefer organized by row? I prefer by row. 1, 1, 1, 1, and 4. This is my first equation. My second is negative 1, 2, 1, 0, and 0. My third equation is 2, 3, 1, negative 1, and 6. And my last equation is minus 2, 1, minus 2, 2, and negative 1. Okay, by the way, I need to double check in the dimension because it's important in the future to understand the dimension. This is 4 row 5 column. It's obvious 4 because it's 4 equation. And it's obvious that the dimension and the column is one more because it included the right hand side. The rest is you put in the algebra any number in the spreadsheet, you create the matrix, and you apply the famous reduce the row echelon form. And I suppose that you get another matrix, same dimension, 4 by 5, of course, different number, and you need to learn how you interpretation this result. Okay, let's do it. Again, switching. This is the thing I don't like. You have to switch into another window, but okay. No, there are no reason. There are no way to do another. Do you see GeoGebra or not yet? Not yet?
Yes, we see it. We see it.
Yeah. Okay. Let me delete everything. Well, you only delete that part. The rest automatically, because it is cause and effect. Because you have no array of number, you have no matrix, you have no transformation. So let me try. Is you correct me if I make a mistake in the number, guys. See, because I make a mistake, I get different result. 1, 1, 1, 1, and 4. This is my first equation. My second, negative 1, 2, 1, 0, no W, and 0, no right hand side. Oh, yes, it's 0. The third equation is 2, 3, 1, negative 1, and 6. Enter. And my last equation is minus 2, 1, minus 2 again, repetition, 2 now positive, and negative 1. Okay. I did well, guys. You double check it with me. See, I make a mistake. Okay. Let me try. You select the numbers, right click, create matrix. Okay. One more time, I checking. Yeah. It's okay, I suppose. Now you again type it here, reduce the row. So reduce the row, reduce the row, echelon of the matrix N1. Wow, look at that. Again, we have that situation. Let me copy this in my piece of paper. Okay, where's my pen? Here. Okay. Is 10000010000100001. Here on the right hand side we have 2 1 0 and 1. What do you think about this? We have solution, yes or no? And what is the solution you see? What is X, what is Y, what is Z, and what is W? No idea?
We have a solution.
How do you know that you see solution? Only one solution. How do you know? What is the clue that give me information there's only one solution?
Look at the last row.
The last row. What happened with the last row? Off. Well, I try to come back to the whiteboard. Whiteboard. Okay, what the hell? Whiteboard, yeah, there you go. Open. What is the information that you believe is one solution? I want to copy. You think 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Okay, enough space. So now the vertical line can separate the coefficients on the right hand side. Right hand side you have 2, 1, 0, and 1. How do you know that we have only one solution? What is the glue to give me information there's one solution? This matrix guy. It's identity matrix, in which the main diagonal is just 1 and the rest is 0. Okay? Therefore, when you try to translate to equation, it's obvious. Okay, the first equation is x equal 2. The second equation is y equal 1. The third equation is z equals 0. And the last equation is w equal 1. And this is the system living in the 4-dimensional context. It's impossible to see geometrically, but algebraically, of course, yes. Each equation represents hyperplane. It's a plane that you never see before in your life, but let's call it algebraically hyperplane. And the hyperplane touching the 4 hyperplane, living in the 4-dimensional space, touching, bang, and only one point is the point whose components are 2, 1, 0, 1. Bam! That is in my finals, my beautiful. Only one, unique solution. Cool? Okay. So you understand? Let's move into a next example. You understand or no?
Yes.
Okay. Example. This is example 4, no? It's example 4, right? Okay. Example 4 look like we are 2x plus y minus c equal 4. Equation 1. Minus x plus y plus 3c equal 1. Equation 2. And that's it. The example is finished. This is given. What do you think about the classification of this system? We have 2 equations only. We have 3 unknown, x, y, and z. Entonces es obvio que this system is underdetermined. So we need more information to get one solution. Pero no, it's not given. This is the system que need to solve it, and that's it. Therefore, it's obvious que you don't expect unique solution. We have infinity many solutions or no solution. I have no idea, But I try to do my best. My best is put the matrix associated with that, que es 2, 1, negative 1, line 4. Negative 1, 1, this is 1, 3, and 1. Okay, this matrix, the dimension is 2 by 4, no? 2 row, because you have 2 equations, and 4 columns. Okay. 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 So now perform the famous reducer row echelon form, and after let's try to interpretation this answer. This is a challenge today. Interpretation. Because the rest, you know the algorithm, the theoretical part behind the algorithm, and the algorithm is too long, I know, but you perform using the computer. Okay. Okay, let me try to do my best. Okay, switching now to the GeoGebra. This is the way I don't like, switching to another window, switching to another window, but definitely we have to. Okay. Do you see GeoGebra? Yes or no? Okay, cool. Everyone makes it here. Okay, cool. Now I don't like it. I delete that one. This is history. Okay, I'm focusing on the new matrix, que es 2, 1, negative 1. We have negative 1, 1, 3, 3, and 1. This is my system. Contain only 2 equations and 3 unknowns. I select, I press the famous right click in the mouse, create the matrix. There you go. Matrix 1, 2, 1, negative 1, 4, negative 1, 1, 3. It's important checking, guys, because you type in wrong, you never get the answer you need. Just again, one more time, reduce echelon, reduce. And remember, theoretically, I expect maybe infinity many solution or non solution, but never one solution, unique solution. And one. Press enter, bam! You get that answer, que look like we are. Wow, don't worry, let me try to, well, I copy, better I copy in the piece of paper the answer. The answer is 1001, negative 4 or 3, 5 or 3, 1, 2. Okay, I copy in the whiteboard. Okay, let me try to copy. Let me try. Okay. Switch. It is raining where? No. Here not raining. Okay, you hear the sound of the rain? Here no, fortunately. Yes, this is maybe another place, but here no. Here is it's sunny, very sunny. Little bit cloud, pero it's actually sunny and not raining. Okay, so now come back. Do you see whiteboard? Yes or no? I copy now. 1, 0, 0, 1, negative 4 over 3, 5 over 3, and 1, 2. And remember, we have a vertical line here that separates the coefficients in front of the variable and the right hand side. Okay, and remember also that this column corresponds with the x, this column corresponds with the y, this column corresponds with the z, and this is the right hand side. And you see something weird. you see something weird because you see the famous identity matrix dimension 2 here. So this is I2. But you see, let me use another color. One extra thing I don't understand very well is this part. Okay, guys, this part that you don't understand very well corresponds with the free variable. Unbelievable. You don't need to do anything. You see the extra block that is outside the identity matrix corresponding with the free variable. Okay. What is the final answer? How you write the final answer? Okay. You understand that the variable x and y gets inside the identity matrix I put in green color is the variable that is non-free. So x and y non-free because they are depending on c gets free. So looking the first equation, you have x no y minus 4 over 3z is equal to 1. And this is the formula that states the relationship between x and c. Okay, I put in countable way like that. You isolate the non-free variable, let's say 1 plus 4 over 3z. Okay. Now, likewise, I take the second equation. The second equation is no x, no, is y plus 5 over 3z equal to. Therefore, you isolate one more time the non-free variable que y as a function of the free variable que es z. Entonces es 2 minus 5 over 3z. Entonces, how you spread the final answer? I know que infinity many solution. I know that we have one free variable, by the way, is z, according to this format. And when you write the infinity many solution, remember, you select the free variable is z, in this case, and inside this, you put this expression, que is 1 plus 4 over 3z, and inside the y, you put this expression, que is 2 minus 5 over 3z. Let me write in elegant way. In elegant way, everyone understand this notation. 1 plus 4 over 3z, comma, 2 minus 5 over 3z, comma, and who is c? C is a free variable. Okay, a free variable is equivalent to say any real number. Infinity. By the way, this solution set, of course, in the three-dimensional space, x, y, and z, I am sure 100% can represent a line. How do you know it's a line? Because we have only one free variable. Okay, therefore the solution set is one-dimension object que living in the three-dimension context. Make sense? Wow. Do you see a beauty? So you don't need to do anything, only interpretation. How you interpret it? Easy. You try to find, as always. Look, in the previous example, the situation was different. In the previous example, the situation was different. You have 1, 0, 0, for example, 3D, 0, 1, 0, 0, 0, 1, the line, and you have three numbers, 2, 3, 4. So we have the famous identity matrix. Let's use it one more time, the green color. This is I3, dimension 3, because it's 3 by 3, no? But you have no here, no, extra block of number. No. We have no that part. Indicate me automatically is unique solution. Unique solution. So this is the format for the unique and the format for the infinity many solution. Well, not always necessarily is like that. Suppose you have, this is another example. You have again, suppose the identity matrix, okay, identity matrix dimension 2, maybe, and you have, for example, one block of the free variable and another block of the free variable. Wow, what the hell? This is X, this is Y, this is Z, and maybe this is W. So in this case, we have two free variables, okay, C and W. And of course, this solution living in the four-dimensional context, however, have two free variables that represent the hyperplane in the four-dimensional space. This idea is confusing, it's a little bit abstract, it's clear. Let me know, guys. Come on, question. Everything is clear? Or I am the best teacher in Miami-Dade College? Okay, everyone understand. Clear! Shane, this is clear. Okay. One more example, example 5. I like example 5. I bring surprise. So I did repetition this and this and this because they are not necessary 1, 2, 3. There are many ways of interpreting. Suppose this example 5. 2x plus 3y minus z equal 3. Equation 1. X minus y minus z equals 0. Equation 2. We have minus x plus y plus z equal 0 again. Wow. And we have one more equation, x plus y plus 3c equal 5. Equation 4. Wow, this is look like we are. How many equations we have in this problem? 4. How many unknown? We have 3. So this is the classical example. It's over-determinant. An over-determinant is very, very weird. Can you get unique solution? But that's possible. There are a few % of probability to get one solution. Because there are many things that need to coincidence. However, it's possible. Potentially, yes. But I don't know. Yeah, I don't care. Because I put in the software, and the software tells me the truth. Okay, set out the matrix. The matrix is 2, 3, -1, bar, 3. 1, -1, -1, 0, -1, +1, +1 again, 0, and 1, 1, 3, 5. This is my matrix. By the way, it's square matrix. It's 4 by 4 because we have 4 equations and 3 unknown, but 1 column extra. For the right hand side is 4 by 4. It's a square. It's okay, but I don't care. It's a square. I put in the software. I apply the famous RREF, reduce row echelon, and let's see what happens. You obtain again another matrix 4 by 4 for sure, but the different number, no? Okay, let me try. Okay, let me share the screen. GeoGebra, classic. Okay, do you see something or not?
Yes, we see it.
Okay, let me be focusing to don't make mistake because I need to type a lot of number here. Okay, this is 2, 3. second is 1, 1, 1 again, and 0. This is negative 1, positive 1, positive 1, and 0. I make a mistake, no? It's negative 1. Hello. It's negative 1. Okay. Well, something's wrong here. Something. Let me delete this cell. Negative 1. Negative 1. There you go. Now the last equation is 1, 1, 3, 5. Let me ask you. You see something weird in the system or no? You see something weird? Or everything is okay? What do you expect can happen? One solution, infinity many solution, or no solution? What do you think can happen? Okay. You are a beginner, so you have no intuition on this. Okay, no problem, I understand. I select, I create the matrix. This is our matrix. Let me double checking the number. Yes, it's correct. Now I put the reducer row, echelon 4, and you put M1. And you get this answer. Let me try to make a screenshot of this answer. Yeah, I put it in the whiteboard. Screenshot. Okay. Let me call example 5. No? Example 5. Example. No, example 5 now. Okay, I come back. I finish this to the whiteboard because I need to investigate this. I need to analyze. Okay, let me switch into whiteboard. There you go. So my whiteboard. Now I have the image that represent the example 5. Example. Yeah. Open. Boom. Look at that. This is my matrix. Okay, I have in my GeoGebra 4x4. I enlarge a little bit. Don't be scared. It's a fraction. The fraction is a number. No? But now the interpretation. The interpretation you see. Wow. Two new things. Number one, the last row is 0, 0, 0, 0. What means that? That means the elimination process discover that there are two equations that are dependent and clear. And it's obvious. Using my intuition, look at that. It's no sophisticated. See, okay, this equation and this equation are linear dependent because if you, for example, you take the second equation and multiply by -1, you get the third equation. These equations are dependent. So this equation do not apport extra information. But actually, apparently, you have 4 equations, but you have no 4 linear dependent, independent equations. You have 2 dependent, and actually we have only 3 dependent. So the system is not over-determined, it's determined, just determined. I can see one more time, the famous identity matrix corresponding with the variable x, y, and z, que es the only variable that we have in the problem. X, Y, and Z. And you can mentally, guys, delete that part. You can delete. When you see one entire equation, que es 0, 0, 0, this equation disappear. Elimination process discover that we have two equations depending. Now the final answer is, it's weird, but it's the answer. X is equal 13 or 9. Y is equal 7 or 18. And C is equal 19 or 18. End the story. That my system que at the beginning have 4 equations actually is in 3D because the dimension depending on the unknown that we have in the problem in the 3-dimensional space. Actually, I discovered that 2 planes is the same plane. But you don't need to elimination discover that for you. Any question, guys? No, it's clear. Okay. Giselle. Okay, I have more examples, but we have more time. Let's practice the same. But you see another new ideas in the interpretation. Look, example, this is example 6, no? Example 6. Example 6 is -4 x plus y equal 5. This is my first equation. 2x minus y plus c minus w equal 5. Equation 2. C plus w equal 4. Equation 3. This is my system que contain 3 equations only and 4 variables. According to the classification of the system is determined, underdetermined, or overdetermined. What do you think? When you have the number of equations is less than the number of unknown is under determined. Would be fantastic if we have another equation, number unknown. The equation is fixed with the problem that you try to solve it. No more equations, so you have no enough information. It's obvious that in this example we have no unique solution, never unique solution. But we have infinity many or no solution, no idea. So I need to create the matrix, apply the procedure in algebra, and after analyze. Let's set out the matrix. The matrix is -4, +1, 0, 0, and 5. This is my first equation. Because Z and W, or whatever you want to call, is missing. In the second equation, you have 2, -1, +1, -1, and 5. Oh, this is completed. And the last equation, we have no x, no y, 1w, 1c, and 1w, and 4. This is my system, expressed in matrix language. This is the system that is 3 by 5. No, let me see. 1, 2, 3, 4, 5 column. 1, 2, 3 equation, of course, 3 rows. Cool. And this is the ready to apply the famous reducer row echelon. Guys, I want in the test, in the reading test, you solving the problem like that. So you have it's given the system. I want to see, can you set out the matrix? You put the chronic. Of course, you go to algebra. You put this, and now you interpretation this. We get a 3 by 5 matrix again, but it's doing. There you go. Is going to algebra. Switching Do you see something? Select and delete. I promise the next time we are working not only using one matrix, several matrices. And you type the one here, over here, and you create and move into the algebra, so you will have the collection of the matrix you need to work in the future, and the case you are doing the operation. And between them. Okay, so now my matrix starts in -4, -4, +1, 0, and 0, and 5. Remember, we have 5 columns. 1, 2, 3, 4, 5. Cool. And the next is 2, -1, +1, -1, and -1, coño, delete, -1, be careful, -1, fine, yeah. And now the last equation is 0, no x, no y, 1, no enter, stop, unbelievable, delete. Okay, S0 again, tab 1, tab 1, and the right hand side 4. Did well? By coincidence, I did well. Okay, now selection, create the matrix. I have my matrix is 3 by 5, and you apply now the reduce row echelon again. It's the only function we studied today, reduce row. I promise the next time we study another function of the matrix. Only one. Bang! I get the answer, and let's see what happened. I don't understand anything. Okay, let's do a screenshot. Screenshot. Okay. This is the example 6, no? I suppose. Six. Save. Switching to whiteboard. Sharing whiteboard. Whiteboard. I try to recover the picture, the screenshot that I did in your journal. You don't need to do this. You copy the piece of paper, hello. But okay, in the lecture I need to do this because I don't know, super is better. Example 6. Okay, open. Long. Look at that. Too big. No. I don't need to put bigger. I put smaller. Do you see very well, guy? Do you see very well? Yes. Okay. Good. Okay. This look like weird because immediately I try to see the last equation. It's no 0, 0, 0, 0, no. And I try to see after that the identity matrix. Well, I see the identity matrix here. Yes or no? And this identity matrix is dimension 3, by 3. Because it's 3 by 3, no? 3 by 3, 9 elements. And we have the famous extra block that represent the flipper. In this case, it's only 1. You can remember, this number is the right-hand side number. after the transformation. No? Original was 554, but now it's negative 37 after, you know, a lot of transformation. So this is X, this is Y, this is Z, but this is W. So now my free variable now is W. Entonces I write equation by equation every variable as a function of W. For example, in the first equation I see 1x plus 1w equal minus 3. Therefore, x is equal minus 3 minus w. So you always isolate the non-free variable as a function of the free. And the second equation, you see y plus 4w equal minus 7. Therefore, y alone is minus 7 minus 4w. Here in the last equation, you see z plus w, because the coefficient is 1, equal 4. Therefore, z is equal 4 minus 2. Entonces, you have the set of the equation que when you are doing in the first test was a little bit complicated because you need to apply too many algebra additional. However, it is easy. The algebra is doing inside this function. Now, just the interpretation. Entonces, now, my solution set, of course, it's infinity, many solutions, because you see one free variable, W, no? And these solutions are living in the 4-dimensional context, because the variable is x, y, z, and w, no? So we have one container for the x expression, comma, one container for the y expression, one container for the z expression, and the last container is w. Okay, w is free. W is all no, any real number. Okay, it's not the same. Because you copy inside this container minus 3 plus w, minus 3 minus w, sorry, minus 7 minus 4w, and 4 minus w. Boom, I finish. Infinity many solution, one free variable get w, and the mathematical expression in between non-free variable is this. Boom, end story. One more example, guys. One more, and that's it. Any question? Do you understand very well? Okay, as you focus in the interpretation. So the heavy algebra and arithmetic behind this is horrible. However, the software help the engineer, scientific study students to make easy and focus on the important part and not 2 plus 2 equals 4. Okay? Of course, in the test, some questions you need to manipulate a little bit, but not too much. The heavy part you are doing in the software. Okay, one more example case. Example, I don't remember the number. It's 7, I guess. Example 7. Okay. Example 7 is say x plus y plus z equal 10. Equation 1. 2x plus 2y plus 2z equal 20. Example 2. Equation 2, sorry. Minus 5x minus 5y minus 5z equal minus 8. Ooh, what the heck is that? You see something weird in this 16i or no? What do you think? We have solution or no solution. Something is weird, no? In this system. You see something or not? Though your intuition don't allow you to see more this, no? No? No idea. Totally lost. A ver. No, yes. Okay, you said no problem. That is the reason que we're using the software. And the software allow you to see clear. Okay. So now, let's move into GeoGebra. Okay, I want to share. GeoGebra. Okay. Let me delete that part. Well, I need to select first. I suppose to select and delete. Okay, so now is the matrix is, let me write here. 1, 1, 1, 1, and 10. Enter. 2, 2, wow, and 20. Enter. And 85. -5. Wow. -5. How many -5? 3 -5. And -50. It's my problem. It's given the test. I select, I create a matrix. Create matrix. I have that. Okay, cool. Now ready to analyze. Reduce a row echelon form of the matrix M1. And something amazing happened now. Look, boom. Wow, wow. What the hell is that? Let me copy the piece of paper. Don't make a screenshot. 1, 1, 1, 10. 0, 0, 0, 0, 0, 0, 0, 0. Okay. Wow, it's weird. Well, I forgot the most important part. No? I am crazy. Look. It's a whiteboard. Okay, I forgot to write the original matrix, but I have practiced typing in the GeoGebra. But no, on the piece of paper I need to see this. 1, 1, 1, 10. 2, 2, 2, 20. -5, -5, -5, -50. Something like that. By the way, this matrix, the dimension is 3 by 4. And I did that. Reduce row echelon. I obtain this matrix is 1, 1, 1, 10. Okay, so that means que the echelon algorithm don't touch the first equation, stay the same. However, wow, the other disappears. Remember, guys, this is one equation that's all 0, and you can, I recommend you, okay, you take the eraser and you erase everything. Actually, my system look like that. This is the bar. Actually, is one equation and 4 columns. 1, 2, 3, 4. The reason is clear. The reason is elimination process discovered that there are 2 equations that are depending of the first. And it's obvious. It's obvious because if you multiply by 2, the equation 1, you multiply by 2, you get the equation 2. So the equation 2 is depending of the equation 1. And likewise, if you multiply by -5, porque no necesariamente number should be positive. It's any number. So if you take one equation and multiply by one number, this new equation after the multiplication is totally equivalent 100% to the original. Actually, this was discovered by the elimination process. Okay, entonces now, es obvio que actually we have only one equation. Only one equation, que this equation living in the 3D context. So it's in the 3D context, one equation. And this equation, let me try to understand the dimension of this object. No? This is x plus y plus z equal 10. No? It's exactly, by the way, the first equation. I prove mathematically that the second and the third is the same, stupid thing. Entonces now, what is that? Es obvio que es a plane. How do you know que es a plane? Because it's one equation. So how many degree of freedom is equal number of variable minus number of equation. So this is always valid, guys. This analysis equation Q equation QN. In this scenario, we have three variables x, y, z, and only one equation. That's dimension 2. It's obvious it's dimension 2 because it's a plane dimension 2. Okay. This geometric is clear. But how do you express the final answer, Professor? Well. Remember, you try to find the famous identity matrix. In this case, the identity matrix is just this one. It's identity matrix dimension 1. How do you know that? Well, depending, no? You have identity matrix dimension 1, que es just 1. Identity dimension 2, que is look like that, 1, 1, 0, 0. But no, because we have only one row, not two rows. So it's dimension 1. So this is x, is the only known free variable. And what about the rest? Well, the rest is this block. This block is a y, and this block is the z. And this problem, obviously, we have two free variables. This is the free variable. And it's logical because free variable, the amount of free variable indicates the dimension of the object. And this is a plane. And the plane is the geometric object dimension 2. Those are two free variables. End the story. Now, what should I do to express the final answer? Easy. Look. You copy parentheses, one container for the x, one container for the y, one container for the z. X, y, z. Because the only thing I should do is express it, the non-free variable is x, as a function of the free variable is y and z. So it's 10 minus y minus z. So in this container, I just copy parentheses 10 minus y minus z. It's just x. Look. And what about the rest of the container? This is y and this is z. And who is y and z? Oh, y and z are any number. So it's y and z are any real number. That is the reason that our solution set have two free variables, is because it's the plane. Actually, the geometric representation of this problem is one plane. Okay, the plane is this equation. We have another plane. Let me use another color. That is the same plane. This is this one. And we have another equation. Let me use another color, but no yellow, blue. The blue equation is the same plane. I prove algebraically que is the same plane. Therefore, the solution is all the points inside this. How you describe that? Using two free variables. Cool? Cool or no? Hecho. Giselle, espera. Guys, I am so proud for this class. Of course, there are exceptions. There are students who failed this class, of course, for sure. But the majority of the students are doing well, very, very well, very, very formal. Your question is good question, smart question, no stupid questions. Therefore, I am so proud. I teach every semester this. For a long time ago, I don't get a class like you. Okay, so continue, guys, because the complicated part passed. Now, chapter 3 is no big deal. You see, it's easy. Everything we are doing software. And chapter 4 is relatively easy, in my opinion, but very, very important in the future in the calculus class. You need to. Let's do it one more or no? One more, the last one, I promise. One more, the last one, I promise. Suppose this. Let me see if I did that or no. No, I don't. Look. Example, I don't remember the name, the number. I suppose, well, I don't care. Is black color. 2x plus y equal minus 3. Equation 1. 2y plus 16 c equal minus 3. Negative 7x minus 3y plus 4c equal 8. Okay. Now immediately I know. I set out the matrix. The matrix is 2, 1, 0, minus 3. The second is 0 to 16 minus 10. And the last one is minus 7, minus 3, 4, and 8. This matrix is 3 by 4. Are you agree or disagree? Agree. Cool. No, because sometimes I make a mistake. I omit one sign. Okay, now let's move into GeoGebra. Okay. Let me try to do differently. Sharing, teaching, GeoGebra. There you go. Do you see?
Yeah.
Okay. Yeah. I don't want to erase because there are no reason. I type in any place the new numbers. 2, 1, 0, minus 3. This is my first equation. My second is 0, 2, 16, minus 3. Okay. My last equation is negative 7, negative 3, positive 4, and positive. I create the matrix immediately because I have no more time. And default, GeoGebra indicate matrix 1, matrix 2. So this now is matrix 2. In the matrix 2, you put a reduce law of the M2, of course. The new problem, no? Let's enter. Bang! And I get the answer. I want to copy in the piece of paper. It's 1, 0, negative 4, 1, 0, 1, 8, negative 5, 0, 0, 0, 0. Oh, I like the 0. I love the 0. Now. I come back to the whiteboard, copy that result. Okay. I suppose you see whiteboard, right? You have 1, 0, negative 4, 1, 0, 1, 8, minus 5, and 0, 0, 0, 0, 0. Guys, if you want, you copy like that, no problem, or you why not erase that part? This equation disappear. Now my system right now is this. Maybe you see more clear. This is the line that separates the physics. And you see one more time the famous identity matrix. And the variable that belong to the identity matrix is x and y. Okay, it's non-free. Non-free. And the free is the other column, the other block. Okay, obviously is. If you write this equation is x minus 4c equal 1, therefore x alone is 1 plus 4c. Y now plus az equal -5, therefore y alone is equal to -5 minus az. And when you write the triple order, because it's in 3 dimensions, of course, this is a free variable, we have the x expression gets 1 plus 4c, comma, the y expression is in -5 minus az, comma, z, you can see is any real. Beautiful. Infinity many solution. I suppose the set belong to the 3-dimensional space, x, y, z. However, for sure, I guarantee you that this looks like a line because we have only one free variable. Only one. Okay, guys, thank you so much for your attention. In a few minutes, I create the video and I send to you. Okay?
Thank you, Professor.
Bye-bye.
Thank you.
Continue like that.